All right, number 3. State the domain and range, determine whether it's a function, and then if it's one-to-one. So pretty easy when they've got it lined out like this. The domain is 1, 2, and 3. And the range is 2, 4, and 6. And what's next? Determine whether it's a function. So you tell me, is that a function?
Yes.
Yep. Yes, it's a function. Is it one-to-one? Yep, because each of those y's also only has one x. And so that's it for number 3. I guess the important thing, and what some people missed on the quiz, was do not write the domain as 1 to 3 as an interval, because it's not 1 to 3. 1 to 3 includes 1, 2, and 3, but it also includes 1.1 and 1.2 and 1.3 and 1.01 and 1. There's there's an infinite number of numbers between 1 and 3. So when you write that as a domain, that is not the domain for this little table. That's an infinitely large set of numbers, and there's only 3 numbers there. So don't do that for domain and range. Make sure you list the points, not give an interval. As opposed to number 4, again, we're ideally doing every 4th one, but sometimes we need to compare, contrast here. Number 4, I could not list all the points. Like if you think it's 0 to 10, that's fine, but it's more than just 0, 2, 4, 6, 8, 10, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's all the points between 0 and 10. So you can't list these. You've got to give the interval for those. So be careful. And by the way, it didn't ask for it here, but that's the difference between discrete and continuous. Discrete, you can list out all the points. Continuous, there's no way to list out all the points because there's an infinite number of points. Number 7. Let's see, just a bunch of ordered pairs. -3, 4. Whoops. Oh, the x-axis is not where I thought it would be. Silly me, I thought it would be in the middle. So -3, 1, 2, 3, 4. At that point. -2, 4. -1, -1. And 1, 2, 3, -1. Okay, so if we can ignore the point that I messed up on. Let's see, what are the directions here? Graph it first. Find the domain and range. So is the domain for this going to be a set or a list of points or an interval? A list. It's a discrete number. So the domain is the x values. -3, -2, -1, and 3. And the range is a list of values, 4 and -1, just 2 of them. Determine whether the equation is a function. So is it a function?
Yes.
Yes, good. If we had included my mistake, it wouldn't be a function, but that dot's not supposed to be there. So yes, it's a function. Is it 1-to-1?
No.
No. Why not?
It's not each.
Okay, so the y values are repeated, or because it doesn't pass the horizontal line test. All right, that's the same thing. There's 2 y values right there. Are these repeated y values? Then state whether it's discrete or continuous.
How do you know?
So discrete is, if you can list all the points, it's discrete. If you have to give a range or an interval, it's continuous. So what is this one, discrete or continuous? Discrete, because you can list the points. Again, we'll do one next to it here. X equals -2. right there. And so domain range, not a big deal. But is that discrete or continuous? That's continuous. Yeah.
So it's another domain range for that.
There's still a domain and range. What values of x does it cover? -2. It's kind of weird. It's just -2. What values of y does it cover? Infinite, so how do I write that? -infinity to infinity. So that's kind of weird that in the x values you can list the points because it's only one. In the y values you have to give a range because it's all of the points.
So that means the x is discrete and the y is...
Well, you don't separate the two. I see what you mean, but there's an infinite number of points, so we would say continuous.
So if one of them is continuous, then it's just continuous.
Yes.
So it still is a function?
Is that a function? How badly does it fail the vertical line test? Like, it couldn't fail it any worse, right? Like it doesn't just hit it twice; it hits it everywhere.
So you're saying if it gives you like a set of points of number 6, it would be discrete, but if it gives you like x equals 2 or like y equals something, it would be continuous?
Correct.
Okay.
I remember what we were talking about in the different class for this one. If you tried to draw the little mapping diagram for this one, how many things would be in the input independent circle here? Like how many? What would be in there? Just -2. And what would be in this? Yeah, like all of them. So you'd have -2 going to. I mean, you couldn't even do this because you would need an infinite number of arrows to cover it. But that would be the best vending machine ever, right? You press one button and you get all of the stuff. It'd be lovely, but it would definitely not be a functioning vending machine. Or for the birthday example, this is one person has all the birthdays. Okay, that's not right. That's not a function. Number 11, g of 4. Okay, good. We're starting with an easy one of these. So this means look at the g function and plug in 4. So I feel like some still haven't figured out what this function notation means. G of x, when there's a function following g of x, that x is just telling you where to plug in the input. Our input is 4. The g function means start with 2 and subtract the square of the input. That's what the g function means. So if there's a 4 in there, we'll plug in 4. So 2 minus 16 would be -14. Move my face out of the way. As opposed to number 14, we would take the f function and plug d in. The f function, plug d in, that would be 2d minus 1. And that's all you could do, because you can't simplify anything. Oh, perfect. 15. We get a little bit more complicated here, but it's the same process. It's just the same concept. The process is more complicated. F of x, again, x is just telling you where to put the input. F of x minus 2 then is the square of x minus 2 minus 4 times x minus 2 plus 1. Whatever's in parentheses is the input to that function. And then we get to see if we can square x minus 2. Hopefully you can go straight to x squared minus 4x plus 4. But having taught it 3 times today, there are definitely people who can't make that skip and need to write out x minus 2 times x minus 2. And hopefully, writing that out, you can now make it to here. If you need to write out one more step, I guess go for it, but I'm not going to do it. Foil that, and you get x squared minus 4x plus 4. The big mistake is forgetting that middle term and thinking you can just square the pieces. That doesn't work. Alright, distribute the minus 4. And now we're just collecting like terms, so x squared minus 8x, and then 4 plus 8 plus 1 is 13. Answer choice A. And reminder that some of the test is free response and some is multiple choice like this. So the review matches roughly the format of the test, where some you answer on your own and some you work out and then hopefully feel confident when you see your answer as one of the choices. We'll come back and get 17 later. Well, let's keep going every fourth one here. On to what I think is the easy stuff here. I hate saying easy stuff and then reaching for the popsicle sticks. I should just reach for the popsicle sticks instead. So no pressure, Evan and Aspen, after claiming this is easy. Prove me right. Evan, what's one of the transformations to number 19?
To the right of 4.
Good, right 4. Aspen, what else has happened? Oh, I could have pulled 3 for this one.
There's a vertical stretch of 3.
Okay. Correct, that's good. Vertical stretch of 3 or by 3. And Carter, that leaves one more thing to account for. Evan took the 4. Aspen took the 3. What's the negative doing, Carter? What's that do to the graph? A negative out front.
Flip it.
Flips it over. Good job. So a vertical flip. Okay, so right 4. Flip it over and stretch it out. So my new slope, remember it's not officially slope, but you kind of use it the same way. Down 3 over 1 on either side. Down because it's flipped. 3 because it's stretched, and we went right 4. Thank you. And I think I've said it before, but please check to see that your picture matches the words. Again, I don't understand where the breakdown is, but usually people make this transition correctly. Like they write down the right stuff, and then somehow, even though all of this is right, there's some breakdown and it doesn't make it onto the graph. And when I hand their test back, they're like, "What? How did I miss that? Because I wrote everything down right, and it didn't make it on there." So again, take 3 seconds to look and see, did I go right 4? Yep. Did I stretch it? Yes. Did I flip it? Yes.
Wait, how do you know when it's a vertical stretch and a horizontal one?
Somebody answer that? How do I know? How did Carter know it was a vertical stretch, not a horizontal one?
It's outside of the absolute value.
Because it's outside. It's outside the X stuff. If it had been like, we don't like doing inside ones. We usually just pull them out front and making them outside ones. It's like 21. You could write it like that and call it a horizontal shrink, but it'd be easier to get that 2 all the way out front, and now it's a vertical stretch. Oh, 23. Something similar is happening on 23. We don't like that negative in there, or the 2 in there. So, let's do this one step at a time. I can't slide a negative outside of an absolute value. Because that, right, you would change its sign. So let's not do that. Let's just factor out the negative 2 from the inside stuff. So that would be x minus 1 plus 4. So the negative feels weird right there, but I can take the 2 out, and I would like to take the 2 out, because if I leave the 2 in, it's a horizontal thing, and I don't really like messing with that. I'd rather it be a vertical thing. And since the absolute value of 2 is 2, no big deal, I can slide the 2 out front. negative 2, absolute value, negative x minus 1, plus 4. Okay, why can I get rid of the negative? Oh, okay, so don't do that. The two negatives make a positive. Well, yeah, but that negative's inside the absolute value, so I can't do that.
You take it out, 2.
What's that?
How do you take the 2 out of the...
I can take the 2 out because the 2 isn't affected by absolute value. The negative sign would be affected. So I can take a 2 out and not worry about it.
So just take it out, that's it?
I can slide a 2 out.
But it's negative because it's the opposite.
And it's, well, this negative was there from the get-go,
Oh.
and that negative I didn't want to take out because I'm nervous about taking a negative outside of absolute value. Because the whole point of absolute value is changing negative signs. Now, before we get too hung up on that, tell me what that does to the graph. Flips it horizontally. What happens when you take that V and flip it horizontally? You got the same thing. So that sort of suggests that if I take it out, it becomes positive, because it doesn't matter. That fits, right? Because if you take the absolute value of a negative, it's positive. So, yeah, you flip it, but it doesn't change anything to the graph. So this one, you kind of have an option. You can leave it there, or you could throw it away because it won't matter. When you flip it this way, nothing changes for absolute value. I guess a parabola would be the same as well. So I'm not really worried about that. It's a horizontal flip, but that has no effect on my graph. Luke?
Does it not affect the negative 1 in the parentheses? So it wouldn't make it a positive 1?
So, well, I need the minus 1 in parentheses with x only. That's why I had to take that negative out. So you tell me, what does that minus 1 do to the graph?
Right 1.
Right 1. And if I'd have left it in there, I might have been confused and thought it was a left 1. All right, how about the plus 4? What's that do? Up 4. And then, goodness, this has all sorts of things going wrong with it here. Don't have enough colors. The negative out front is a vertical flip. So that definitely matters, because that went from pointing up to pointing down. Landon?
You just took a 2 out, right? So how did the x minus 1, how'd that turn negative?
So, looking just at that, I took a negative 2 out of both of those things. That's where that became negative, because I factored out a negative 2. Right? If I divide both of these by negative 2 to factor it out, 2 divided by negative 2 is negative 1.
How is it still negative after you, like, in front of the x?
Because from here to here, I took the 2 out, but I left the negative. Because I can't slide a negative outside of an absolute value. But I can slide a number out. I think maybe you're stuck seeing the negative and the 2 stuck together. But that's a negative and a 2, and I can separate those and factor out a negative. Right? Some people like, oh, I can't reduce negative 5 and 5 because those are the same. Or those aren't the same. You're like, well, no, of course you can. The 5's reduced to 1, and the negative stays there. It's kind of that thing. The negative stays there, and I'll take the 2 out.
Question. Are there going to be questions on the test like this where you have to simplify?
So if you'd have stopped before saying, yes, there are questions on the test where you have to simplify, no, the negative issue isn't as bad as this on the test.
Okay.
So write 1 up for vertical stretch of 2 and flipped over. And I sort of ignored the horizontal flip, but we already talked about that. If you flip it that way, it doesn't matter. By the way, if you're worried about any of those points, you could plug them into the original and check and see what happens. So like I think 3, 0 is a point on the graph. if you're not sure about that, plug 3 in and see what happens. So that would be negative 6 plus 2. That would be negative 4. Absolute value would make it a positive 4, but then the negative on the front would make it negative 4 again. Negative 4 plus 4 is 0, so I just verified that that point's right. I mean, I wouldn't do that on every graph, and you'd save that to the end, but if you were absolutely wanted to make sure, or you did a whole bunch of things, and you're like, man, I don't know if I got that right or not, well then, pick some points. If you plug in 0, you ought to get 2. If you plug in negative 1, you ought to get 0. So you can pick some points and see if it matches, and then you can have hopefully more confidence that your picture is right. We'll come back to this sliding things in and out in a minute. Oh, like almost right now in a minute. Number 3. Oh, let's pick on some people because I think we can do these. I say that 7 confused a few people. Rachel, how about number 3? What's the change to the parent function? Compare these two things. Those are not the same. Right? This one would be left 2, but this one is up 2. So the plus 2 at the end is an up and down thing. Some people got confused on 7, probably because we didn't do a whole lot of rational graphs. But if I rewrote it like this, then could you answer what the transformation is? It makes it a little more obvious, I think.
Vertical stretch.
Vertical stretch. Because you're multiplying by 3. I mean, I didn't have to do that. If you could look at this and know it's a vertical stretch, then great. But a lot of people are like, wait a minute, what's that 3 doing? If I will just rewrite it like this, then it's a little easier to see that I'm multiplying 1 over x by 3, which means it's a vertical stretch. It's just a way to see that it's a vertical stretch a little bit easier.
So on number 1, can the fraction of that 2, would it just be the up 2, just up 2? Or just be
Which one?
Number 3, negative 1 over x, would that just be up 2?
Yes, that one's up 2.
Just up 2?
Just up 2. Because 1 over x is the parent function.
Oh.
And it was a good question from someone earlier today is, you're not going to have to graph all of these because we did not graph 1 over x. I mean, I want you to recognize the graph, but you didn't have to graph it. So I would expect you to be able to tell me the transformation, but we didn't graph those with transformations, so you won't have to graph that. All right, and then finally number 11, the absolute value. That's the one we're most familiar with because we did a lot of work with that. Vertical up 3, so that'd be a plus 3 at the end. Left 9. I know the plus 3 is at the end, that's the easy part. How do I get a left 9?
Plus 9.
Yeah, x plus 9. Right, the x stuff is backwards. Oh, just to prevent someone from making a 98 and being frustrated with me, probably. If you don't put a y equals on there, it's not an equation. And if the question says write the equation and you don't have y equals, I'm going to take off a point. And you're going to be mad at me because you made a 99. And I'm going to say, well, it asked for an equation. You need to give me an equation.
Is it the same?
Either one. You could also say f of x equals, so that's fine.
That's what I was going
Okay.
to say.
Okay, that's the ones I wanted to work, so that concludes like section 3 or video set number 3.